Hello guys, today I'm going to show you how to make a boost converter using XL6009. Firstly, why do we need a boost converter? Boost converter, it converts a lower DC voltage to a higher DC voltage. It is up to the converter specifications to convert from what DC voltage you want to a certain value of DC voltage. Okay, why do we need a boost converter? We could need a boost converter in applications such as using solar cells, battery powered applications, or even consumer electronics. So what options do we have before making a boost converter? Firstly, we have the option of making our own switching frequency oscillator using MOSFETs and PWM generator, something like that, using Arduino or some other controller. Else, we could just use a ready-made IC that can be which has oscillator, compensator, everything inbuilt in it, and just try to improve its efficiency. We'll go with the second one because it's easier one and easy is good. So I told about XL6009. So why are we going to use XL6009? I'll tell about it using the datasheet XL6009. You can search about the datasheet from Google. Just type XL6009 datasheet, you'll get this datasheet, and its features are it has a 400 kilohertz switching frequency oscillator inbuilt in it, maximum 4 ampere switching current, and it has a very high efficiency of 94%. It's available in TO263 5L package. Its applications are given here. You can have a look. Spin out is given here. You can have a look. Okay. First pin is ground. Second is enable. You can leave it floating as well as you can connect to any high, more than 0 volts. Switch SW, we have to connect to the boost converter topology. We'll tell about this later. VIN is connected to more than 3 volt input voltage, and feedback pin is connected to you can connect to a resistor divider as well as a potentiometer. In our project, we'll be connecting it to a potentiometer. The internal diagram of XL6009 is something like this. It has a very good topology. It has a compensator, everything inside. You can have a look if you want to know more about it. I'll just skip it, and I'll tell about the features like feedback voltage. You can give up from 0.3 minus 0.3 to V input. Like other things are input voltage from 0.3 to 36. Actually, this is not 0.3. It is 3 volts to 36 volts. I've tried in 0.3. It doesn't work. And a soldering temperature is like about 260 degrees Celsius. Just make sure it doesn't exceed 260 degrees Celsius, otherwise you'll be frying up your IC. The feedback voltage can be like minimum 1.2 to 1.287. This is not that important. Efficiency is about 92 to 94% at 2 amps. 5 to 32 input voltage. It has inbuilt power MOSFET in it. That's why it's able to give a 4 amps switching current, and it has a frequency oscillator ranging from 320 kilohertz to 480 kilohertz. That's that's it. That's why we are using XL6009, because it has good features and it is definitely cheaper than other boost converter ICs. So now we are going to see how we are going to use the XL6009. Okay, we will it's very hard to get XL6009 directly in the market. Suppose I gave you two options. The first option was to make a boost converter using discrete components and make your own frequency oscillator circuit, and the second one was directly using the XL6009. And the second option is hard to get the IC. It has to be ordered online, and in the first option it's easy to get the components, but the circuit is not reliable. So we get this module of XL6009, something like this. You have to make it something like this. You have to remove all the components from it, especially this IC. You have to scrap it out from here, and other components you can use your own. Actually, this is we're actually reverse engineering this thing. XL6009, you already saw this in the PDF. Okay, the circuit, the input capacity. Sorry, imagine this as the IC. I just created a block out of it. Okay, you have to connect a capacitor in the input side. It can be of any value. Okay, just have to check the voltage. So it can be the lower the voltage, the cheaper the capacitor. So just use the voltage which is within the range, input voltage range. I have used a 25 volt 220 microfarad capacitor in the input, and inductor I wrote here 10 microhenry, but you can use 10 to 30 microhenry. Anything will work. Okay, this is actually the boost converter topology. Okay, an inductor in series with a diode, and in between we have to apply a switching pulse. Okay, which is given by the XL6009 IC. This is a Schottky diode. We are using a Schottky diode because it has very high switching rate, as well as it has low forward voltage. So we are using a Schottky diode. And in the feedback pin, to control the duty cycle of the oscillation, we are using a potentiometer. In the output side, you have to be careful to use a capacitor which has a rating more than 50 volts, because the output voltage range is 5 to 60 volts. Okay, so I have used a 220 microfarad capacitor and having a rating of 63 volts. Read it to you in a short while. Okay, this is the output capacitor which is 63 volts, and the same rating capacitors 220 microfarad, 220 microfarad. try to get this. This is a voltmeter. This is just to show the readings, and this is, I have also kept a decoupling capacitor in the input side, and this is the to check whether if I'm using a solar panel so that no reverse voltage occurs. So I've used a diode here. The Schottky diode is here, okay, and this is the IC. This is basic soldering done by me. I'm not that good at this is the circuit, okay, and this is the battery. This is like a cell phone battery. It has a maximum of it can give 3.8 volts, okay. So as soon as I connect, oops, connected the wrong thing, I connected it, and now wait, showing the voltage that was stored in the capacitor. Slowly discharging. The output capacitor is slowly discharging, and let's see, you can see 3.8 volts.
As we rotate, the voltage increases. Okay.
The maximum it can go is up to 57 volts. I have not used the right exact components mentioned in the datasheet. If you use the exact components mentioned in the datasheet, you could get 60 volts too. Okay, I don't have oscilloscope, so I couldn't show you the waveforms. The waveforms are pretty good. It doesn't have much of distortions, harmonics. This is actually a pretty good IC. If you can scrap out the thing from the module, it can be a cheap and easy to make project. Okay. If you want to check it out using the multimeter tool,
sometimes people don't believe me. You see, 54 volts output from a 3 volts battery. So this is it. Show you how the boost converter works.
thank you so much for watching. Have a nice day. Please like, subscribe, and support.